Good morning, everybody. Welcome. Welcome back to Calvin. Plan for today is we're going to spend class talking through the rest of Standard 15, this process of finding intervals over which power series will converge. I know, craziness. Oh, now that I start talking, everybody else starts. I've got my usual office hours today from 11 to noon and 1 to 2, as well as tomorrow from 1 to 2. Don't forget, you all have a homework set due tonight on ratio test, homework set due Friday on power series, and let's see, an exam Monday, midterm 3, that'll have every standard on it. And then we'll also have a quiz on Friday over Standard 15. That's right, today is the last day of the semester. I'm not going to be giving you a test or a quiz of some sort. From here on out, every time I see you, I'm going to put a quiz in here or something in your hands. I have a big old pile of things to pass back. I think I got caught up yesterday on the grading front, so go ahead and do that. Let's see who wrote up. Mary. Yeah. Sarah. Katie. Katie. Jonah. I don't go in. You're not actually. Here you go. Out. Alrighty. So, should be caught up on retest grading at this point, as well as regular quiz grading. If you feel like you're missing something, let me know. I will check to make sure it didn't get missorted somewhere. And from here on out, it's just one more quiz, and then the 2 exams, the midterm 3 and the final exam. So, 4 friends one day who were doing really well in calculus decided to take a weekend road trip instead of studying for the final. Not surprisingly, they drink too much, oversleep on the morning of the final, get back to campus after the exam is already over. One of them concocts an explanation and asks for the professor's mercy. Professor, we went to my parents' cabin for the weekend so we could have a quiet place to study. Driving back on Monday morning, we got a flat tire, and we didn't have a spare. It took hours for help to arrive. Please have mercy on us. Professor says sympathetically, okay, I understand. Come back tomorrow morning and I'll give you a makeup exam. So Tuesday morning, the professor seats the students in the four corners of a very large lecture hall. The tests are just one page. They are already on the desks, and the professor tells the students to begin. On the front side of the paper is just one question involving a definite integral, and all four students solve it easily. On the back side of the paper is an even simpler question. Which tire was it? That's what they got their stories straight. And with that, let's go back into talking about power series. So, on Monday's class, we started talking about what happens if you have a series that's defined by a function. And that led into a discussion of a specific type of series called a power series, where the idea behind a power series is that you have essentially like an infinite polynomial. You have like positive powers of x minus some constant c, raised to higher and higher powers that could potentially go on forever. And the question that we're going to be looking to ask, at least in standard 15 with these power series, is given a function that's defined in terms of a series like this, what values of x, or what values can we plug in for x that would give us a convergent series, versus what values could we plug in for x that would make this a divergent series. And so last time, we looked at an example series, sum from n equals 1 to infinity of 2 to the n over n times x minus 5 raised to the nth power. And in order to determine what values of x can we plug in that'll cause the power series to converge, we use the ratio tests, where we took, if this was our a sub n right here, 2 to the n over n times x minus 5 to the n. We took a limit as n goes to infinity of absolute value of the n plus first term in our series divided by the nth term, which came out to 2 times absolute value of x minus 5. We said, well, we need that to be less than 1 in order for the series to converge. When we did that, we got absolute value of x minus 5 had to be less than a half, meaning x minus 5 had to be between a half and negative a half, which when we added 4 to both sides gave us 4 and a half, had to be less than x, had to be less than 5 and a half. So we said that the series is going to converge for all values of x between 4 and a half and 5 and a half. We also had to check 4 and a half and 5 and a half manually, owing to the fact that if we had something like 2 absolute value of x minus 5 equal to 1, which is the same as saying x is 4 and a half or 5 and a half, then the ratio test didn't tell us anything. Remember, ratio test kind of fails to give us any information if we get an r value of exactly equal to 1. And so we checked each of these manually by plugging them in for x in the series. In the case of 4 and a half, when we plugged that in, we got something like negative 1 to the n over n, the alternating harmonic series, which we said converged conditionally. And at x equals 5 and a half, when we plugged that in, we ended up just getting the regular harmonic series, 1 over n, which we said diverged as a p series, p equals 1. So it turns out that the power series we looked at converged over the interval from 4 and a half to 5 and a half, including 4 and a half, not including 5 and a half. And I kind of drew out a little number line here to illustrate what's going on at different values of x. So at x equals 5, which by the way is our c value, the center of the power series, we said that everywhere from 5 going to the left towards 4.5 and on the right towards 5.5, the series had to absolutely converge according to the ratio test. That's when we got the r less than 1 case. To the right of 5.5 and to the left of 4.5, the series diverged. That was when we got the this expression greater than 1. And at 4.5 and 5.5, the ones we manually checked, we found that at 4.5 it conditionally converged, at 5.5 it diverged. And that's where we left things off last time. Any questions or comments before we look at kind of the more general case? Groovy. So, turns out, whenever you take a power series like this and you use the ratio test to determine where that power series is going to converge, you're always going to end up in a scenario like this one, where it's going to absolutely converge on some interval centered at the center of your power series. To the right of that interval and to the left of that interval, it's going to diverge. And at the endpoints of that interval, anything could happen corresponding to r. That's where you get a value of r equals 1. And we actually have a theorem that'll kind of sum that up, say exactly what will happen if what will happen. I'll quote me there for a second, in order to tell when the power series converge. This is the power series convergence theorem. And what this theorem says is, given a power series, big F of x is some infinite sum of a sub n times x minus c raised to the power of n. There exists a positive number r called the radius of convergence. Of the power series. Satisfying the condition that, first of all, big F of x converges absolutely if the absolute value of x minus c is less than the radius of convergence, which is the same as saying that x has to be between c plus r and c minus r. The power series is going to diverge if the absolute value of x minus c is greater than big R, which is the same as saying either x is less than c minus r or x is greater than c plus r. And finally, big F of x could do anything if absolute value of x minus c is equal to big R, which is what's going to happen in the case where x is equal to c plus r or c minus r. So what does that mean? Well, if we draw that out on a number line, what that's going to tell us is we're always going to get a number line like this, looking at our power series, that looks pretty similar to this one. Actually, let's put it over here. What it means is we're always going to get some interval from c minus r to c plus r, where to the left of C minus R, we're always going to get power series diverges. To the right of C plus R, we're always going to get R power series diverges. At C plus R and C minus R, it could do anything. Those are the points where you would typically have to manually check for does the power series converge or diverge. And then finally, everywhere in between C minus R to C plus R, our power series is going to absolutely converge. So that's kind of the graph of what we're saying in the power series convergence theorem. That if you're between C minus R and C plus R, you converge and do it absolutely. To the right of C plus R and to the left of C minus R, you diverge, and at C plus R and C minus R, those 2 points themselves that are exactly distance R away from the center of the power series, you could have any of the 3 conditions. You could have absolute convergence, you could have conditional convergence, you could have divergence. So as a quick example, if we go back to this power series here, what's the radius of convergence for this power series? Keeping in mind that the radius of convergence is always going to be the distance from the center of the power series to sort of the 2 endpoints of the interval over which it absolutely converges. So, Jonah, what would you say is going to be the radius of convergence in this case?
Half.
Yeah, it's going to be 1/2, the distance from the center of our power series C to either 5.5 or 4.5. Distance either way is always going to be exactly 1/2. So we're going to get a radius of convergence of big R equals 1/2. But Dr. Gerstle, we've used big R to talk about like the limit thing in the ratio test. Why are we using big R to talk about radius of convergence now? Are those the same thing? No, they're not the same thing. And that's annoying because now we're using the variable big R to kind of refer to 2 different things in the same problem. If you want to blame someone, blame the fact that the word ratio and the word radius both start with the letter R. But from here on out, whenever we're talking about power series and we talk about big R, we're not going to be talking about this thing anymore. I mean, we're going to be talking about this, we're just not going to be calling it little r. We're going to be talking about this radius of convergence. This that's the distance from the center of the power series to the 2 endpoints of the interval over which we have the absolute convergence. Questions, comments, concerns? Yes, Jonah?
All right.
Okay, give me a smile. That's great, I appreciate that. Alright, so in other words, what this theorem is really just telling us is that the sort of pattern we found from doing the ratio test on our power series on page 2 is going to generalize pretty nicely. You're always going to have this interval in the middle where you have absolute convergence. Always have these intervals on either side where we have divergence. The only thing that might really change from this picture is what's happening at the 2 endpoints of the interval of convergence. And that's just going to, you're just going to have to always check those 2 points manually on a series by series basis. There's no kind of fast, easy to recognize pattern for are these 2 endpoints going to be absolutely convergent, conditionally convergent, or divergent. Could be any of the 3 in any combination. So let's do another example. I'm going to flip the page here. My packet on the flip. I'm actually going to skip a page for now, and which we'll come back to, and take a look at this big G of x. Excuse me, I can't talk today. Expression, which will be sum from n equals 0 to infinity of n factorial times x plus 5 raised to the nth power. So if we write that out, we're going to get 0 factorial times x plus 5 to the 0, which is 1, plus 1 factorial times x plus 5 to the first, plus 2 factorial times x plus 5 squared, etc., etc. And our goal is going to be, how do we determine where this power series is going to converge? How do we start this? What process do we use to find our interval according to our last example? Bethany?
So we use the ratio test?
Let's do the ratio test on this bugger. To do the ratio test, we'll need to take a limit as n goes to infinity, a sub n plus 1 over a sub n. Absolute value of all that, of course. Sarah, what's going to be the n plus first term in our series, the a sub n plus 1 here?
Would it be n plus 1 factorial? And then times x plus 5 plus 1, or no, sorry, times x plus 5 to the n plus 1 power.
Like that? I like it. Yeah. Again, the n plus first term, someone's having fun, is just going to be, go back to your original formula for the series. That's your a sub n. To get the n plus 1 term, you're just replacing your n's with n plus 1s. And in this case, we're going to get n plus 1 factorial times x plus 5 to the n plus 1 over, hey, we can actually just write this as a single fraction this time. Our a sub n term is just n factorial times x plus 5 raised to the nth power. Joy, if we take n plus 1 factorial and divide by n factorial, what are we going to be left with?
N plus 1.
Yeah, n plus 1 factorial over n factorial. Remember, n factorial is n times n minus 1 times n minus 2 dot dot dot. N plus 1 factorial is n plus 1 times n minus 1 times n minus 2 dot dot dot. So when we take these two factorials, they're just going to cancel out to leave us with an n plus 1. Katie, what's x plus 5 to the n plus 1 over x plus 5 to the n going to give us?
Just be x plus 5.
Yep, times x plus 5. And Maria, as n goes to infinity, what can we say about absolute value of n plus 1 times x plus 5? For any value of x?
If x is greater than 5.
If x is greater than 5, that'll certainly go to infinity.
Yeah, and then if it's less than 5, it'll go.
Also, hint, I don't think anything interesting is happening at x equals 5 exactly.
Oh, go 0. Or also go to infinity, sorry. I don't know.
So what value of x, so there's only one value of x that's going to make this not go to infinity. It's not x equals 5. Because if you plugged in 5, you just get n plus 1 times 10, which would go to infinity. What value of x would make this go to some other value other than infinity?
-5.
Yeah, it's actually at x equals -5, where the interesting stuff is happening here. And Nathan, if we were to plug in -5 for x into this expression, what would that limit go to?
0.
It's going to go to 0. So when we do the ratio test on this one, we actually get that there's only one single value of x that we can plug in that would make this limit right here come out to something that's finite, and that's if we were to plug in x equals -5, literally the center of the power series, which would give us 0. Anything else we plug in for x here is going to give us a limit of infinity. Bethany?
So would there be any way that it could be negative infinity?
Good question. I would say no, mainly because of the absolute value bars. If we didn't have the absolute value bars there, then if we plugged in some value of x that was less than -5, it would go to negative infinity instead. But the fact that we have these absolute value bars here means we're never going to get anything negative out of this limit. It's always going to go to positive infinity except at -5. Does that make sense? Good question. So with that in mind, what does the ratio test tell us about where the series is going to converge? Jonah?
So would it only be absolute convergent at -5 and then divergent everywhere else?
It would indeed. Yeah, because we need this value to be less than 1, don't forget. Well, Mary, is infinity less than 1?
No.
Is 0 less than 1?
Yes.
Yeah, so in order to get that this limit comes out to something less than 1, that's only going to happen at a single point at x equals -5. So to kind of answer our question, where does this power series converge? Surprise, we don't actually have to check 2 endpoints of an interval or anything like that for this one. It converges only at a single point, only at x equals -5. And it's going to diverge everywhere else. What's the radius of convergence of this power series? In other words, if we had some interval over which the power series converged, what's going to be the distance from the center of the power series to the endpoint of either of the endpoints of that interval? James?
0.
Surprise! We get a big R equals 0 in this case. Because unlike the previous example where we had this interval of length 1, or radius 1/2, where the power series converged absolutely, here we only have a single point at which that happens, at -5. So at the single point we have absolute convergence. Everywhere to the right of that point and everywhere to the left of that point, we're going to have divergence in this case. So we technically could have a radius of convergence of 0 like this. No matter what your power series is, if you plug in the center of the power series, in this case -5, it's always going to be absolutely convergent. Because if you plug in the center of the power series, you're just going to always be adding 0 over and over and over, which if you add 0 to itself, that's always going to converge. In this case, if we plugged in -5, all the x plus 5 terms would come out to 0. But sometimes you do end up with series like this one, where your power series is gonna converge exactly at one point and nowhere else. Yeah, James?
So is there still a way to show that the radius of convergence is 0 algebraically by sort of like breaking that up and then setting it less than 1 and then dividing by limit as n approaches infinity of n plus 1? So then you
Sure.
can that on both sides.
Sure, so what you basically end up with if you do that is something like absolute value of x plus 5 needs to be less than 1 over infinity. So you can say, oh, here's your radius of convergence right here. It's 1 over infinity. What's 1 over infinity going to be?
0.
It's 0. So that would be kind of how you would do that algebraically. Similar how we got a half over here when we ended up with something like 2 absolute value of x minus 5 less than 1. We divided both sides by 2 to get x minus 5 absolute value had to be less than a half. And this formula right here told us, hey, that 1/2, that's our radius of convergence. That's how you would kind of do that algebraically over here. Now technically, I am cheating the rules all over the place by saying, oh, divide both sides by infinity. Just to be clear, that's kind of an intuitive idea more so than something you can do formally. Don't divide by infinity, kids. Infinity is not a number. Don't do drugs. Stay in school. But that's kind of the general idea, at least, of what you're doing there. A little bit sloppy here. But
Well, would it be fine if you just kept it in the limit form?
I mean, if you only converge at a single point, then you're always just going to have a radius of convergence of 0. You can always just think of that as being like a special case. So to speak.
Okay.
Any other questions or comments? Let's see. Nora. Now, I'm going to give you a quiz on this standard on Friday. What do you think you might expect to see on the quiz?
A problem.
What kind of problem?
A power series convergence problem.
A power series convergence problem. Yeah. Friday's quiz. I'm going to give you one power series and say, find me all values of x where this power series converges. And you'll have to kind of go through this process. So what I thought we could do for kind of the rest of the class, I would give you all the opportunity to work on a few problems yourselves. There's 3 more power series in this packet, including the one I skipped over on the previous page. So what I would like for you all to do is take some time, and as always, I encourage you to work with / talk with your neighbors. For each of the other power series in this packet, see if you can determine A, what's the interval, what values of x would cause this power series to converge versus diverge, and B, what's the radius of convergence for each of the remaining power series. So go ahead, take a few minutes. As always, encourage you to work with your neighbors and or ask me questions and see what you can make of these other series, and we'll look at 1 or 2 of them here in a bit as a class. Yes? Yeah, that's what I did. Let's swing a couple. Oh goodness. All right. You need a packet? Oh, okay. You said. Anybody else need a packet? What's up?
Confused by the radius convergence in that problem.
Sure. So radius of convergence basically says you're taking the distance from the center of the power series to kind of the edge of the interval over which it converges. Technically, in this problem, it's the same point. You're finding the distance from 5 to 5, because 5 is not only the center of the interval, it's also at the edge of the interval. And if I were to ask you the question of how far away is 5 from 5? What's the distance from 5 to itself? You would say it's 0. So that's what radius of convergence means. Distance from center of power series to edge of that interval, which in this problem came out to a half, because you're looking for distance from like 5 to 5.5. In this case, 5 to itself just has a distance of 0.
Okay.
Does that make sense?
And 0 is, in this case, greater than the absolute value of x minus c.
Well, basically here, zero, think of zero here as being, zero is not equal to this limit. Well, it is at -5, but that's besides the point. Zero here just is referring to sort of this distance right here. So whenever you do one of these problems, you're always going to have some distance from center to endpoint, right? And typically, what I like to do is at the very end of the problem, kind of look back and say, hey, we have this interval, maybe it's just a single point, but most of the time it's going to have some length to it. What's the distance what's half the length of the interval? Or in other words, the distance from the center to one of the two endpoints. This is kind of the general process we go by there. Yeah, what's up?
How would you cancel out n-1 factorial over n factorial? That just becomes 1 over n.
I think so. As n factorial is the same as n times n minus 1 times n minus 2 times n minus 3 dot dot dot. N minus 1 factorial is n minus 1 times n minus 2 times n minus 3.
Okay.
So everything will cancel out but the 1 over n when you do that. As always, don't be shy about talking to your neighbors and or flagging me down if you have any questions. Wanna just take a look at something. Hey, Lauren, what's up? One thing you might start by doing is instead of dividing by a fraction, multiply by its reciprocal. So you'll have this times n to the 7th over x minus c. That'd probably be a good next step to do if you're confused on how to split it up. So why don't you try that first? Yeah, keep the first fraction the same. Because that one you're just multiplying by. So this one. And then you're multiplying by the reciprocal of the other fraction where you're swapping the numerator. And then once you do that, the way I recommend approaching this is, looks like we have two types of terms here, an n to the 7th, stuff to the 7th power term, and an x minus 3 to the 7th power terms. So I would probably split this up into this term over that term, times that term over that term. And then you can start trying to simplify the individual fractions or see what happens as the individual pieces go to infinity. I'll let you think about that a little bit.
I think so.
I'm an adult. Calm yourself, please.
Hi, sir. So we're going through this one, just making sure the logical is up here. Is this just gonna come out to 1 7?
No. You can't split this up into two separate fractions. You can do that if you have a sum in your numerator and a single denominator, but not if you have two terms added in your denominator.
Okay.
So what I would just do is think about n over n plus 1. So if you're looking at fractions like 1,000 over 1,001 or 1 billion over 1 billion 1, what are those get really, really close to?
1.
And if you take one thing going to 1 to the 7th power, what's thing going to 1 to the 7th power go to?
1.
There's your answer.
Learning after today.
Yeah, n over n plus 1 to the 7th is just gonna go to 1, because n over n plus 1 by itself would go to 1 as n goes to infinity. Let's try writing out each piece separately. So it's n minus 1 over n. Okay. So if I were to ask you to write out kind of an expression for n minus 1 factorial, what would you get?
I get the n.
First term's n minus 1,
Yeah, well, yeah.
and then you have the whole n minus 2 times n minus 3 all the way down to 1, right?
Yeah.
And n factorial, that's how the factorial works. I mean, you don't have to include the times 1, technically you could end it at times 2, and it would give you the same thing, because multiplying by 1 doesn't change anything. But factorial by definition is just you take in an integer and you multiply every integer from that down to 1.
Oh, yeah. Yeah, yeah.
Cool. And then n factorial is going to be the same thing, except you'll have an n in the front, right?
Yeah. Well, because it's just so
So if you take these fraction over that fraction, what will that simplify to? You got it? Yeah, if we were to have an n plus 1 factorial, we're starting at n plus 1 and then multiplying by n times n minus 1 times n minus 2 times all the way down to 1. Exactly. 5 times 4 times 3 times 2 times 1, which is the same as 5 times 5 times minus 1 times 5 times 1. And factorial is a little bit tricky because we don't work with those as much as we work with like a lot of the other like exponential type stuff.
I was confused with the. Oh, I see.
Sure, sure.
I think we got to the rate part now. I think we're back at the point where I need my hand out.
Okay.
Do we do something like this, where you just set the greater or less than 1 equal to 1?
Yeah, you can do that. So
Or
you want
is there
let's
more
look at the
like-
less than 1 first.
Is there more like streamlined way to do that?
Sure. So you got that when you took the limit, right? The absolute value of x. Let's set that less than 1 first to find where it's absolutely separate. What did we say last class about absolute value of thing less than 1 or 10 or whatever? Means that expression has to be between what two numbers?
-1/2 and 1/2.
That was the case when we had absolute value was less than a half.
Just 1.
Yeah, it has to be between -1 and +1. In this case. And in general, whenever you have absolute value of say x minus 3 is less than c, that always tells you that this expression inside your absolute value, in this case x minus 3, would have to be between -c and +c. See the shiny c? And then you can like add 3 to both sides of the inequality to find what x would have to be between instead of just like x minus 3. Does that sort of make sense?
I think so, I just don't like doing algebra.
Yeah, well, I don't like your attitude, but here we are.
Hi, sir.
James, what's up?
So does this mean that R approaches infinity so that this just converges
Yeah.
everywhere?
What's that?
You get it?
Well, as n goes to infinity, what's that expression going to go to?
Alright, 0. What do you
For every value of x?
figure that out?
I think so.
Well, in that case, if you get that limit always comes out to something less than 1, that would imply it absolutely converges everywhere from the ratio test, I guess. Sort of the opposite of
Yeah.
this problem up here where it only converged at one point. It could converge everywhere theoretically.
Wait a minute, are we dropping the absolute value or did we get that?
Right, I don't agree with
Yeah, so.
this simplifying to n minus one.
When you do absolute value, that's essentially.
Mary and I just kind of talked about that one. If you write out n minus 1 factorial, you get like n minus 1 times n minus 2 times n minus 3, etc. If you start at n factorial, you're going to get n times n minus 1 times n minus 2 times n minus 3 and so on. And when we cancel out all the terms, like terms from numerator and denominator, it's going to come out to 1 over n, not n minus 1 in that case. And I think that might kind of change up your interval a little bit too.
If I plug in 1/2, I get -2.
Well, what did we do in the ratio test when we came out to something like a sub n plus 1 over a sub n when we came out to a limit of, call it L? What had to be true about L in the ratio test in order to get absolute
I
convergence?
know why, I just can't say it.
What number did L have to be less
Plug in
than?
any value that makes that.
Yeah, so essentially what you're doing is you're taking this expression and saying, what does x have to be? What values of x will make that less than 1, equal to 1, or greater than 1? Absolute value of x minus 1 in this case. Well, if it's less than 1, it's absolutely convergent. L greater than 1 is divergent. L equal to 1 is the one where you have to kind of check manually. Yeah, so in this case, your L would be some expression in terms of x. X minus 3. So you might have to find what values of x are going to make this less than 1, which would give you absolute convergence. What values of x are going to make this greater than 1, which would give you divergence. And what values of x would make that equal to 1, which would be kind of the ones where you have to plug those values into the series manually to check.
Okay, so you're not really finding a finite value for convergence, you're just finding a range.
Yeah, you're finding sort of an interval of convergence rather than just like, oh, it's at this particular value of x. Usually, I mean, that example was kind of a weird one where we only had one value of x. Usually we're going to have infinitely many in some interval like this.
Okay, yeah.
Sure.
Yeah.
What's up, Gabe? Well, what's the absolute value of -1? And if you multiply something by 1, what do you get? Thing doesn't change. Yeah, I would agree. Alright. This one? So, how I would probably simplify that? We have like n to the 7th over n plus 1 to the 7th. I would probably say that, hey, these two have the same exponent, so you can actually combine them into n over n plus 1 to the 7th power. And then that fraction doesn't really simplify at all. So instead you might think about, as n goes to infinity, what's n over n plus 1 do? So if we're looking at fractions like 5, 6, or 99 over 100, or a billion over a billion and 1, what constant number are these getting closer and closer to? To me, this looks like really close to, I would say, 1.
Yeah, that's what.
Like 99 hundredths, that's like very, very close to 1. It's only 100th away from it, right? So I would say that this is going to be equal to 1. So if you're taking something going to 1 to the 7th power, what's 1 to the 7th power going to be? So I would say this whole thing is gonna go to 1 as n goes to infinity. Does that make sense? We got really quiet all of a sudden. That's spooky. Oh, good. Let me check over here real quick. I spent like the whole time over there. How are you all doing over here? Is it Yeah.
Just wanna make sure that like checking the endpoints. Is that how you do it?
Yeah, you just literally plug it into the series and then use some other test to say, oh, hey,
What? Sorry.
that looks like a convergent series. We'll change the series test, that would be a P series, P equals 7, so it converges. That would be how you do it.
Thank you.
No, it's it's just, you're just.
Yeah, that's the part I'm gonna ask about.
So now you
I don't really know where to go from there.
Think so? Nope, that's 0 over something going to infinity is gonna go to 0 really fast.
So I think that's gonna be I think that's gonna be converge, and then outside of that, that's gonna like, someone can do that same.
So what's your radius of convergence gonna be then?
So what's C in this case?
So it converges over vehicle
Say what?
Oh yeah, so C is 3, and then
So it converges everywhere.
1.
Alrighty, job question.
Within,
Yeah, I had a question about why
so C
if I
was
just did this right in
R, so
general.
your R is
Because I feel like that's like a very unsatisfying answer.
Why is that unsatisfying?
I don't know, just like 1 over E.
Oh no.
Sorry.
Oh no, it's not nice numbers. Whatever will we do?
Okay.
Yeah, no, you're on the right track.
Okay.
Yes.
I just so
is it the rate, is it the?
so you have that so far.
Are you on J right now?
Yeah. So you have that, so then I divided E.
It's not gonna be less
I
than
made it,
I
zero.
got R as 1 over E.
Well, it's gonna be equal to 0.
So I didn't use.
No matter what your x
The
is.
rate.
So yeah, it would always be less than 1.
Less
If
than one.
it's always less than 1, like
Now
that's
how
how
we
you
do that,
series.
and then divide by E on each side.
Absolutely.
You go for
That
here.
makes 2 seconds, it's like
Where?
C plus R.
So what are your two?
There.
It makes the next one.
I got -2 minus 1 over E and.
Turns out that one's gonna be absolutely convergent everywhere.
Yeah, I had that too.
Yeah.
I had to give you one line
How
for
is
that
that?
just to show you
My
that
question
it
is,
can
how is
happen.
2 in the middle of
I
that?
started this one.
Center.
I started this one. Everyone started this one.
Oh man, well, the first one the first one's
because of
similar.
the-
It actually has like the
how
smaller
we're doing it
interval,
where
like the original.
It's less than
solvent
1, it's
did,
convergent.
which is why I put that one first.
But if it's
Well,
not,
I
I
don't
guess-
know why people go different places. You start in here, so you just you actually go to the next one.
What's the midpoint formula
That's
again?
what shit happens.
Let me put it this way. I usually put easier problems towards the front of the packet,
Well, does
harder
that
ones
work
towards
if
the
one's
back.
positive and one's negative?
Now you have
So to build up a progression of difficulties is my general strategy. So, the first one's a little bit easier, that one's a little bit trickier. One after that
+2.
is a little bit trickier still, perhaps.
So the radius convergence,
Wait,
what would that
I think the middle might be negative 2.
No? What's the distance from the center of your interval to the outer endpoints of the interval of convergence?
So that's the rate.
Oh no, that's
R
R
equals infinity.
Yeah, if you take the average, it's
Sort of the opposite of the
1 over
big
E
G of X we did up there.
So it's, yeah,
Instead of
negative
just
2.
converging at a single point, it converges everywhere. So instead of having a
The
radius
limit of
of
n going to
0,
infinity
it's
doesn't
gonna
really
be
apply just because there's no more n. I guess, kind of. I mean, it's still there, but
So this was for this values. Checking over.
I mean, yeah. So then, so we do like
So basically you need to
is
check
between
2 and 4
negative 1 over
manually
E
for
and
convergence because inside the interval from
Yeah,
2
so
to
how we
4,
think-
ratio
so we
test
did-
tells you that it converges absolutely.
I
To the left of 2, to the right of 4, it diverges. to determine what's actually going on at 2 and 4 themselves, you have to go back
So
over
for
the
the absolute values,
plug in 2 and 4.
it could either be
And then take a limit as n goes to and then
rid of
just
the
see what
absolute value
happens
side, we
with
say
those
that
individual
1 over
series.
negative 1 over 2
minus
less than
3
x
to the
plus 2.
end. So that'd be like negative 1 to the end over into the 7.
Kind of weird now.
We've talked about how to determine whether individual series like that converge in X meters.
Okay.
Why don't you take a look at that? Let me get Gabe first, and then I'll do you, and then I'll do
Is greater than x plus 2.
what's up, Gabe?
Yeah.
Oh yeah. So will one of these always be the absolute value of the other?
Say what?
Because there's like how we do this when we get to this point, it's always like they're the same thing except this one is
You could certainly plug, let's see, if you plug in 2 and 3, you can get negative 1 to the end over minus 1
There's gotta be some pattern there. There's like,
I think
it feels like there's
something
reference
you
every
should
time.
Yeah, but
to
like
do the ratio test on
it
these
makes sense
individual
if you just
things.
think about
Like
it
this one, I
because
mean, like this.
this is always the same and then one is
Well, then,
always
that could take
that
some time
minus
perhaps.
that number and then one's always that plus that number.
This one,
Yeah.
I'm gonna guess the ratio test.
Yeah, so this one will always
Try to do a ratio test.
so one of them will
I think
always
this
be
one you could actually just do alternating series tests on to say it converges.
So
Because denominator's going
yeah,
to
so I think
infinity as
one
n
will
gets
just be
big.
the alternating.
And since it's alternating and the individual terms go to
Well,
zero,
one is
it
the
converges.
other one is
This one's a little bit tricky,
like what's it called?
so you might want to try a ratio test on that.
So looking at.
Let's see.
Joy. Looking at 4, I think that one has.
That's just stupid at this point, just like telling everyone how to do it.
So then,
I've already done all of them.
then you just subtract 2
Zero
from
is
the
indeed
side,
less than 1, so.
create inequality.
Yeah.
Yeah.
How you derive like an actual answer.
So in that case,
Divergence from that.
What you probably need to do is
well,
take a limit.
Well, once you subtract 2,
As
that'll
n
tell you
goes to
after what
infinity
converges
of,
because they do set
into
that
the
less than
7
1.
over
Yeah.
n plus 1 to the 7.
Kind of.
That's gonna come out to some constant, and based on what that constant is,
Oh,
that
yeah,
can tell
so
you what's going on for values
when you
of
pull
x,
this out,
other than negative
Um,
three.
every answer you get there will be and also you don't need
Think
to
about that
use
limit.
these ones.
And I'll give you a hint,
How did
you can always write that as
Yeah.
n over n plus 1,
Because that's what
the whole
you.
thing raised to the 7, might be easier to work with.
Yeah, we just had to do that up there because it was a weird case.
What's up, James?
Oh, so I was wondering, in this, will this always be the alternating version of this one, and this one's always the absolute value?
Good question.
Yeah, because
Answer's generally gonna be yes.
okay, yeah, because this is always like a negative R and this is always a positive R. That's
Yeah.
just raised to the end.
Yeah, with the basic idea is if you plug in the 2 endpoints, you're either gonna get 1 to the n or negative 1 to the n.
Yeah.
So yeah, you're right, one's always gonna be like the alternating version of the other,
Yeah.
so to speak. Nora. Holy moly, let me see. So you take that, so you get n plus 1. I think you have x to 2 to the n plus 1 over x plus 2 to the n, not the other way around.
Right, okay.
Yeah, so you'll have e times x plus 2.
I'm thinking of it as like,
But
if
you're
you're
at
at
negative
-2,
so
and then you.
Yeah, those find out.
Well, if you have something like, well, if you have something like,
Yes, so then I think it's better.
so you end up with something like that, right?
Because
So
then
if that's less
if
than
that
1,
is converged,
what
then
has to be true about absolute value of x minus 2?
Oh, it must be less than 3.
You got it. So that's how you can find your radius of convergence, I think. Well, let me check back here again, and I haven't really checked in with like
Yeah.
Sarah and Ally. How are you,
So then,
how are the 2 of you doing?
what does that say about?
Well, I have no easy way to get
So
to you.
now
so
you know
we'll
that
forever
if x is in
answer.
between these two values, that it will be.
But I'm thinking of it as like. You were to have.
Well,
Right.
Despite how messy they are still just numbers that it's in between.
If the ends cancel out, then when you take a limit as n goes to infinity, you don't have to do anything. Yeah, if there's no ends there, then as n goes to infinity, the expression is just gonna stay the same. Only time you need to actually do something, you have to
Yeah.
actually go to infinity.
I mean, it's basically the same thing we just did, just with an E instead. Essentially, like I think we did on previous pages.
Yeah, you were explaining
And then on each side, one is always of the form C minus R,
So I
and
think
one's
this
always
is
C
gonna
plus
come out
R.
to just
So you know that C is
absolute
value
value
two,
x
and then
minus
you know that
3
R is one over these.
times 1.
Yeah, I don't know, I was getting.
Yeah,
And I think what you'll end up needing to do, Marn, is to look at,
I don't really know.
is to look at, this, is you end up with.
I just do it, I don't know what
I just work with the numbers,
Yeah.
and tell numbers.
Basically,
Because technically you have something like,
Because this is like adding.
absolute value of x minus 3 times 1. What's x minus 3 times 1 give you? You sort of end up with this expression. Sort of like how in the original example, we ended up with something like 2 times absolute value of x minus 5.
Which one is one?
So then the idea is you need to set that to be less than 1 and solve for x in order to get where's the values of x that will make it absolutely converge using the ratio test. Hold your horses. What's up, Joanne? I kind of prefer like an interval, or like,
Something like that.
The J of X?
yeah, something like that would be
H
good.
of X.
Can I do both?
Yeah.
Sure. Oh, you could absolutely.
Because I feel like if I screw
Zero is
this
less
up,
than
I
1,
have
so
to-
absolute
because
conversion.
this like makes.
If you screw that up and you have the number line right, that smells like an n minus to me.
Damn, okay.
I have a question. So with this.
Yeah, it's kinda weird too. It's like the opposite of that one, I guess.
Yeah.
Is that the
That's what he
distance
said.
from the
I don't
center
know.
to
I don't know why, but it just is.
X is 1 times
What's the
X
distance?
minus 3.
What do you have to add to negative
It's like
2
when
to
the n
get
goes to
negative
infinity,
2 plus 1 over e?
and into that,
Yeah, okay, so.
it's
It is.
0.
Hold on,
Which
they,
means that using the ratio test, you 0 at all values less than 1.
oh gosh, I had to do a problem as a class and we ran out of time.
Dr. Curse.
Speed run.
Speed run, okay. I mean, I'll post my solution, so. Alright, I just want to make a couple quick announcements because class is set to officially end here in just a couple minutes. So, I had intended to do one of these as a class again, but we kind of ran out of time. I wasn't paying enough attention to the clock because I was going around answering questions. Oh, good questions, by the way. So what I'm going to do is I'm gonna have my solutions posted later this morning on Canvas. I encourage you to try out all 3 of these problems for yourselves, the ones we didn't do as a class, and yeah, try all 3 of them out. See what you can make of them. And if you get stuck, I'll have my solutions up to kind of maybe give you a guide, give you some tips. But it's definitely better if you try working them out on your own before going and looking at my solutions. And as a reminder, if you go to the modules page on Canvas, I do have solutions for everything we've done over the course of the semester, other than out-of-class retests. Students take those at different points. You might be taking the 1B retest like week 1, someone else might take it like next week. So I don't want to do that, but all the in-class quizzes and exams and all the packets have solutions on Canvas. Alright, with that, we are out of time for today. We'll do a quiz on Standard 15, and then I'll spend a little bit of time talking about the Taylor series on Friday. Hope y'all have a good one. See you all then.
It's not cheating, you just have a really good study.
Oh yeah, I mean, don't use it while you're doing like an in-class quiz or a retest or something, but like to help you prepare for things. Like that's what they're there for. Give you something to check yourself on. See ya. Take care. Congrats, and let's work around that. Okay, so the plan was what? Friday you take this midterm 3, Monday you take the final? Okay, sounds good. Just send me an email to remind me.